You can use equation-driven curves to create lots of different and complex geometry in SOLIDWORKS. One drawback to equation-driven curves, however, is that the curve cannot be self-intersecting. In this lesson, I'll show you how to create a cycloid and epicycloid curve in SOLIDWORKS. A cycloid is a curve that's generated by a point on a circle rolling down a straight line. The path of the point as it travels down the line is the cycloid curve. This type of curve can be really useful in SOLIDWORKS if you're trying to create pathmates, either for an animation or some other use. To create a cycloid curve sketch, I'll first begin a new sketch on the front plane. In this case, just a regular 2D sketch. Next, I'll go to Tools, Sketch Entities, and select Equation-Driven Curve. You can create 2D equation-driven curves in two ways, either explicitly, by entering an equation for y in terms of x, or parametrically, by entering equations for both x and y in terms of t. We'll use the parametric type. The equation for a cycloid is pretty simple. For the x component, I'll enter the radius. Let's use 5 inches. So, 5 times the quantity t minus the sine of t. If the equation appears in black when you're done entering it, it should compute just fine. If you aren't using the proper syntax, the equation will appear in red. Now for the y component. I'll again begin with the radius, 5, times the quantity 1 minus cosine t. I can have t go from 0 to 2 pi to view one full rotation of the cycloid. And when I click the green check, the equation is created. I can edit the equation by selecting it in the graphics area, and the property manager appears. I'll change the t value to 4 pi so that we can see another rotation of the cycloid. If you try to increase the t value more than this, you might get an error from SOLIDWORKS saying it cannot create the curve, because the curve will be discontinuous. If you need more than 2 instances of the cycloid, simply exit the equation-driven curve and use the copy feature to create the additional instances. As you can see from the sketch, the cycloid shows the motion of a point on a circle rolling down a straight line. Now, let's look at creating an epicycloid. An epicycloid is just like a cycloid, except instead of rolling along a straight line, the path is circular. Epicycloids can become quite complex, and in certain cases can be self-intersecting. This happens when the ratio of the inner circle's radius to the outer circle's radius is a non-integer. Without going too much into the math behind this, the ratio represents the number of times the outer circle will travel around the inner circle in 360 degrees. Although, you may run into additional problems if you need the non-integer ratio, simply due to the way SOLIDWORKS handles self-intersecting geometry. Let's start by looking at an example where the ratio is an integer. I'll again begin a new sketch on the front plane, and go to Tools, Sketch Entities, Equation-Driven Curve. I'll choose the parametric option. To put this equation in generic terms, I'll use the letter A to represent the radius of the inner circle, and B to represent the radius of the circle that's tracing around it. The generic equation for an epicycloid looks like this. For the x component, it's the A plus B times cosine of t minus B times the cosine of the quantity A plus B over B times t. Let's use 20 inches for the inner radius and 5 inches for the outer radius, giving us a ratio of 4. I'll enter it now. 20 plus 5 cosine t minus 5 times cosine of 20 plus 5 over 5 times t. The y component is identical to the x component, except you use sine where cosine was used. I'll simply copy and paste the x component over and change the cosines to sine. Now, I can specify a range of values for t. Again, SOLIDWORKS gets picky and won't let you create any self-intersecting geometry or any discontinuous curves. Really, I want this curve to go from negative pi to pi, but SOLIDWORKS won't let me. For the range, I'll specify negative pi over 2 to positive pi over 2, and I'll click the green check to complete the curve. Now, I can use the Sketch Mirror tool to create the other half of the epicycloid. Now, in the previous example, we chose 4 as our ratio. If the ratio instead was a non-integer, say 5½ instead, we wouldn't be able to even create half the curve due to self-intersecting geometry. And this is unfortunately a limitation of the software, and is inherent in the way SOLIDWORKS calculates and creates geometry. However, you can sweep the curve up a helix to get the same result when you look at it normal to. Let me show you what I mean. Instead of starting a 2D sketch, I'll start a 3D sketch. Now, I'll again go to Tools, Sketch Entities, Equation-Driven Curve. In 3D sketches, all you can create are parametric equations. Using the same generic form of the equations as before, I'll enter 11 plus 2 cosine t minus 2 times cosine of 11 plus 2 over 2 times t. I'll copy and paste the x component to the y component, and I'll change the cosines over to sines. For the z component, I'll enter t, and I'll have t go from 0 to 20. When I click the green check, the epicycloid is created. Looking at it normal to, you can see how it would be self-intersecting if it were drawn in 2D. However, if I exit the sketch and rotate it a little bit, you can see the curve is instead rising through 3D space, ensuring that it doesn't self-intersect. Now you can use this sketch as a sweep path, or whatever you need an epicycloid for.